Welcome to Sankalp Learning Classes. So in this session, we'll be discussing the chapter determinants. In the chapter determinants, we will have 1 mark question, then 2 mark, 4 mark, and 5 mark questions. Okay, so in this session, we'll be dealing with 1 mark questions. Okay, before that, we'll just have a quick reflection on what else we have studied about determinants. Okay, so I know you're all familiar with matrices, right? So this is actually a concept related to matrices itself. And you know what is a determinant, right? So what do you mean by a determinant? What do you mean by a determinant? Determinant is actually related with the square matrix, right? So in this chapter, we'll be only dealing with square matrices. We have studied about different types of matrices, right? So we'll be studying about the concept is limited to square matrices only. So it is dealing with square matrices. And what is this determinant and square matrices? How are they related to each other? How are they related? Determinant is a real number that is associated with a square matrix. Okay, so you are associating a real number to a square matrix. Okay, you are giving a real number to a square matrix that is known as a determinant. So there are in this chapter we'll be considering 1 by 1 matrix, 2 by 2 matrix, as well as 3 by 3 matrix. So what do you mean by this 3 by 3 matrix? Square matrix, it is just a square matrix of order 3, right? And what do you mean by 2 by 2 matrix? 2 by 2 means it is a square matrix of order 2, right? So we'll be dealing with these three order matrices. Okay, so so we understood what is a determinant, right? So the determinant is denoted by determinant. You can see in the screen, right? So this is the notation of determinant. Okay, it is read as det A, determinant of A. Okay, I hope you can see this, the notation. All right, and we can find out the value of 1 by 1 square matrix, 2 by 2, as well as 3 by 3. And how do you do that? How will you do that? If you are given a matrix, 1 by 1 matrix, okay, so consider matrix A is equal to A11. So this is a 1 by 1 matrix. How it became a 1 by 1 matrix? It has only 1 row and 1 column, right? So what is the determinant of this particular matrix? Determinant A is nothing but that element itself. It has only that element. So that element itself is the determinant of that 1 by 1 matrix. All right, this is how you find out the determinant of a 1 by 1 matrix. And if you consider 2 by 2 square matrix, okay, how will you write the general form of a 2 by 2 matrix? You know, it is written like this. Sorry, it is 1, 2, right? First row, second element, right? Now consider second row, first element, second row, second element. So this is a general form of a 2 by 2 square matrix. How will you find out the determinant of a 2 by 2 square matrix? You just have to find the product of the diagonal elements first, right? So this is equal to determinant of A is equal to, first find out the product A11, A22, then minus, then you have to find out the product of non-diagonal elements. Okay, so that is minus A21, A12. All right, this is how you find out the determinant of a 2 by 2 square matrix. And now what about a 3 by 3 square matrix? How will you do that? There are different ways to find out the determinant of a 3 by 3 square matrix. Since there are 3 rows and 3 columns, you can select any row or any column and you can expand along that row or column in order to find out the determinant of a 3 by 3 square matrix. All right. So here, if you consider a 3 by 3 matrix, A12, A13. First row is completed, A21, A22, A23. Then third row, A31, A32, A33. So this is how you write the general form of a 3 by 3 square matrix. You have to find out the determinant of this matrix. Okay, how will you do that? Okay, if I am selecting this first row, if I am selecting this first row, and I'm going to expand along this first row in order to find out the determinant. Okay, so consider the first element. Okay, and now what you have to do, you have to multiply it with the minor of that element, right? What is the minor of that element? You have to delete the row and column containing that element, which means this is the first row and first column, right? So first row and first column is deleted. And what about the remaining elements? That is known as the minor of that particular element. This portion, okay, you can see here, this portion is known as the minor of that element. What do you mean by this minor? Minor is nothing but the determinant, okay, determinant value, okay. So minor A22, A23, A32, A33. Okay. The minus the A12 into, consider the second element, right? And then you have to delete the row and column containing that element. So what will be the minor? That is A21, A23, A31, A33, right? Then plus, okay, plus A13 into, then you have to delete this column and this row. Okay, so what is remaining? A21, A22, A31, A32. And now you can find out the determinant of this one, right? This is a 2 by 2. 2 by 2 determinant, so you can easily find out. How do you do that? You have to cross multiply and then subtract, right? Okay, so this is how you find out the determinant of a 3 by 3 square matrix. And the properties of determinant is given. Determinant of AB, matrix AB. Okay, A into B is the matrix multiplication of two matrices, right? So the determinant of AB is nothing but, we can split it, determinant of A into determinant of B. All right. Now, the another important property is determinant of A transpose is nothing but determinant of A itself. If you find out the determinant of a matrix and you are asked to find out the determinant of its transpose, it is actually the same. So you need only find out the determinant of that matrix. Okay. Okay, then you'll get the determinant of the transpose of that matrix. All right, now we are moving on to the next concept. Okay, so this, if A is a square matrix of order n, then determinant of k into A is equal to k raised n into determinant of A. What do you mean by that? That is, k is a scalar. Okay, k is a number and that number is multiplied into a matrix, multiplied with the matrix A. All right, so you will get another matrix and you have to find out the determinant of that particular matrix. So how will you do that? How will you do that? That is given here. K raised n into determinant of A. And what is this n? N is nothing but the order of the square matrix A. Okay, order of the square matrix. You take K outside, the value of K outside, then you put the power of the square matrix and then into determinant of the given matrix A. Okay, so this is actually very important and you'll get many problems related to this. Okay. Now, minor and cofactor all we have explained, right? Minor is nothing but the determinant that is obtained by deleting the ith row and jth column. Okay, if you consider an element Aij, how do you obtain the minor of that element? You deleted the first row and first column, right? So if you consider A11, you have to delete the first row and first column, then you'll get the minor of that particular element, right? So in general, if it is Aij, then you have to delete the ith row and jth column in order to obtain the minor. And what do you mean by this cofactor? Cofactor is nothing but signed minor. Okay, what is it? Signed minor. That is, if, for example, if you consider a matrix, A equal to matrix 2631. Okay, so this one is a 2 by 2 matrix. This is a 2 by 2 matrix. You have to find out the minor of these elements. How will you find out the minor of the element? First, consider this one. Okay, so it is the position 1, 1, right? First row, first column. It is element in the first row, first column, right? So M11. So that is equal to minor of that element. We are finding out minor of that element. Okay, that is equal to, how will you do that? You have to delete the row and column containing that element, which means you have to delete this column and this row. Right, this column and this row deleted. So what is remaining here? Actually, since it is a 2 by 2 matrix, there is no other minor there. So it will be that value, 1. Okay, it is 1. Now, what is M12? M12 means first row, second element. First row, second element means you have to delete this row and this column, right? Which column? this row, this column. So what is the element remaining? It is 3. And what about M21? M21, you have to delete the second row, first column. Then second row, first column, you can see second row, first column. What is remaining? 6. Right? So 6 is the answer. Then what is the minor of M22? Minor of M22, which means the minor of this element 1. You have to delete the row and column containing it. So this is a row and this is a column containing what is the element? It is 2, right? So this is how you find out the minor of a matrix. Okay, minor of elements, right? Minor of elements given in a matrix. All right. So now you have to find out cofactor. What do you mean by this cofactor? It is signed minor. And what is a signed minor means? Yeah, the value is same, but if you add this row and column, that here the value of row is 1 and the value of column is 1, right? So 1 plus 1 is 2. If it is an even number, you don't need to change the sign of the value. Okay, it is plus 1 itself. You don't need to change it into minus. Okay, if the answer is an even odd number, if you consider A12, 1 plus 2 is here, 1 plus 2 is 3. It is an odd number. Now you have to change the sign of that value. Which value? The minor value. Minor value is 3. Now you have to change it into minus 3. Okay, since here it is an odd number, you have to change it into um, the opposite sign. So it will become minus 3. So this is known as signed minor. All right. What is A21? A21 is also similar, the same case, right? 2 plus 1 is 3, right? It is an odd number. Now you have to change the sign. So it will become minus 6, right? What about A2? 2 plus 2 is 4. It is an even number. So you don't need to change the sign. Okay. So this one will be 2 itself. This is known as the cofactor of each element, right? Cofactor of. Now you can write this as a matrix. You can construct the cofactor matrix, right? So what is cofactor matrix? Cofactor matrix of A is equal to, this is A11. So write it in the position 1, 1. A12, write in the position 1, 2. Now A21 is minus 6, A22 is 2. So this is a cofactor of that matrix. And now what do you mean by the concept adjoint? Adjoint is nothing but the transpose of the cofactor matrix. It is the transpose of the cofactor matrix. So how will you write the transpose of the matrix? Change the row into column, right? So adj A is equal to, what do you mean by adj A? How will you find out adj A? You have to find out the transpose of this particular matrix, which means you have to write this row as column 1 minus 3. Now this one row minus 6 to 2 should be written as a column, right? So this is known as adjoint of a matrix. Okay, and this was explained in order to understand the concept of minor, cofactor, and the relation between cofactor and adjoint. Okay. Actually, finding a adjoint of a 2 by 2 matrix is very simple. If it is asked for 1 mark question, you don't need to do all these steps. You just need to, the matrix was this, right? A is equal to matrix 2, 6, 3, 1. So if it is asked for a 1 mark question, you don't need to find out minor, cofactor, edge, etc. Right? You can directly go to finding out the edge of a matrix. How will you do that? You just have to interchange the diagonal elements. Okay. So edge A is equal to, interchange the diagonal elements means here in the place of 1, it will come, it is 2. I'm sorry. Here it is 2. So instead of 2, it will be 1. And instead of 1, it will become 2. Interchange the diagonal elements. And what happens to the non-diagonal element? You just change the sign of the non-diagonal element. So change this into minus 6. Since here it is 6, change it into minus 6. Here is 3. Change it into minus 3. Okay. So this is finding out the joint of a 2 by 2 matrix. Okay. Interchange the diagonal elements. Change the sign of the non-diagonal elements. All right. So in this method itself, you can find out the minor, cofactor, adjoint of a 3 by 3 matrix also. The only difference will be if you are eliminating the row and column, you will get another minor, right? Because there will be 4 elements remaining. So you have to find out the determinant of that particular minor also. All right. Okay. Now we are moving on to the other important concept, that is, this is very important property, A into at j equal to j into A is equal to I into determinant of A. All right, so this is given in a theorem. So this is an important property in order to solve certain MCQ questions. All right. So that is important. Similarly, this one is also important. Determinant of at j is equal to determinant of A raised to n minus 1. Okay. Now, what do you mean by the inverse of a matrix? How do you find out the inverse of a matrix? If you are given a square matrix A and you have to find out the inverse of that matrix, the condition is that the determinant of A should be not equal to 0. Determinant of that matrix should not be equal to 0. That is, there is a concept called singular matrix and non-singular matrix, right? If determinant A is equal to 0, then that matrix is singular matrix. This is very important concept, singular matrix. If determinant A of a given matrix is not equal to 0, then such matrix are known as non-singular matrix. What it is called? It is called as non-singular matrix, right? So if a matrix is a non-singular matrix, that is, if the determinant of that matrix is not equal to 0, we can say that the inverse of that matrix exists. All right, inverse of that matrix exists. And how will you find out the inverse of that matrix? It is nothing but adds of that matrix divided by determinant A. What do you mean by adds of A? Adjoint of the matrix divided by the value of the determinant of that matrix will give you the inverse of that matrix. All right. So inverse of matrix has also different property that is given. The most important is A inverse of the whole inverse is equal to A itself. AB, the whole inverse, is equal to B inverse, A inverse. All right. Now, we are moving on to the application of these determinants. So the determinants has important application. The main application that you can see here is in order to find out the area of a triangle, to find out the equation of uh, to find out the equation of lines, and as well as to solve linear equations. Okay, equation of line, then to solve the linear equation. So the first application is given here. To if you are given the vertices of a triangle, okay, you can find out the area of that particular triangle using determinants. Okay, that is given here. Area is nothing but half into determinant of you can arrange the vertices of the triangle in this form. Okay, it is given here x1, y1. Then you put 1 in that row. Then x2, y2, x3, y3. The third column should be completely 1. Okay, if you solve this, that is, if you find out the determinant and then you divide it with 2 or 1 by 2 into that determinant value, you will get the area of the triangle. All right. If all these three vertices, okay, if all the three vertices are in a line, what happens? You can't form a triangle like that, right? You can't form a triangle with the same points in a line, right? Which means area of the triangle is 0, right? Area of the triangle will be 0. You can't form a triangle, so the area will be 0, which means if area is 0, that is, if this value is 0, if this value is 0, you can conclude that the points given are collinear. And what do you mean by this collinear? Collinear means the points in the same line, right? The points lying in the same line, that is known as collinear. So if the area of a triangle is 0, we can conclude that the points are collinear. All right, now we are moving on to the next application, that is solving the system of linear equations. We can solve the system of linear equations using matrix method. Okay, that is given here. If you are given 3 equations like this, you have to solve the values. That is, solving linear equations means you have to find out the value of x, y, z. Okay, the value of x, y, z can be find out by using the matrix method. That is, you have to convert this linear equations into matrix equation. Matrix equation Ax equal to B, where A is a matrix, X is a matrix, B is a column matrix. Okay, B and X are column matrix. Okay, that is given here. X is equal to X, Y, Z. B is equal to these numbers, D1, D2, D3. And what about this A matrix? A matrix is nothing but the coefficient of all these unknown values. Coefficient of unknown values. So first, the first row is the coefficients of the first equation. Okay, second row is the coefficient of the second equation. Okay, that's how you write the matrix A. Okay, and then you can find out x by taking this a to the other side. That is x is equal to a inverse b. X equal to a inverse b. If determinant of a is not equal to 0, then we can say that the given system is consistent and it has a unique solution. Okay. Then the second condition, we are only dealing with this type of problems, but you have to be familiar with these two conditions also, because these are asked for 1 mark questions. Okay. If determinant of A is equal to 0 and adj of A into B is non-zero, then we can conclude that the given system is inconsistent and it has no solution. Okay. And the third condition is, if determinant A is equal to 0 and adj of A into B is equal to 0, then we can say that the system is consistent. The system is consistent and it has infinitely many solutions. Alright. It has infinitely many solutions. Okay, so these were the important concepts that you have studied in this chapter. Now we are going on to the questions. All right, so this is the first question. If A is equal to K into B, where A and B are square matrices of order n, then determinant of A is equal to. Okay, you have to find out the determinant of A. How will you do that? You have studied this property, right? If this matrix A is equal to, you have to find out the determinant of A, right? And what is this A matrix A? It is nothing but K into B. And what is this K? K is a scalar number. So you can apply the property K power n into determinant of B. Okay, since A is a square matrix of order n, this can be written as K power n into determinant of B. So which is the answer? B is the answer. Okay, which means if, for example, if you are given a matrix A of order 3, A of order 3, so what will be the value of the determinant A? Determinant A is equal to, this is order actually, the order of A is equal to 3. So determinant of A will be, it will be, it is determinant of 3 into B, right? So you can take this 3 outside and then you find out the power, 3 power 3 into determinant of B. Okay, if the number is 5, that is if determinant of A is equal to, A is given as 5 into B. A is given as 5 into B. Then what is determinant of A? Determinant of A is equal to determinant of 5B, right? And how will you find out the determinant of 5B? That is nothing but 5 power cube. How did I write cube? Because the order of the matrix is 3. So 5 cube into determinant of B. Okay, this is how you find out the answer. Alright, now we are moving on to the second question. So the second question is the value of the determinant. So they have given a determinant. You have to find out the value. It is a 3 by 3 matrix. It is a 3 by 3 matrix. So I am going to expand it along the first row. Okay, since it has a 0, I am going to expand it along the first row itself. You can take any row or any column. So I am taking the first row itself. So first, you take the first element, right? First element is 0. 0 into, right? 0 into, you have to consider the minor 0, which means you have to delete this column and this row, right? So it will be 0 sine beta, right, minus sine beta 0. Okay, then minus. Okay, minus. And why am I putting a minus here? Because this is the A12 element, right? A12 element. So the addition 1 plus 2 is 3. Since it is an odd, we have to put a minus there. Okay, minus. Second element is sine alpha, right? Sine alpha into the determinant is, you have to delete this row and the column. Okay, so that is minus sine alpha, sine beta, then cos alpha 0. All right, now consider the third element. Okay, this is our third element, right? So delete the row and column. Okay, so which means it was minus cos alpha, I think, right? Yes, minus cos alpha into minus sine alpha 0 cos alpha minus sine beta. Okay, now you have to find out the determinant. This is actually you don't need to find out. 0 into any number is 0, right? 0 minus sine alpha into minus sine alpha into 0 is 0 minus cos alpha into sine beta. Okay, then minus cos alpha into this one minus sine alpha into minus sine beta means sine alpha sine beta, right? Minus 0 into cos alpha is minus 0. Okay, now what is the answer? Minus sine alpha into 0 is 0. The second one is plus sine alpha cos alpha sine beta, right? Now, what is the value here? Cos alpha sine alpha sine beta. Cos alpha sine alpha sine beta, right? Then cos alpha into 0 is 0, right? So the value, the both are same. Sine alpha, sine beta, cos alpha. Both are same, right? So what is the value? Value is nothing but 0. So which is the option? First option. A option is right. Okay, now we are moving on to the third question. So this is our third question. If determinant of 3x x1 is equal to determinant of 3 2 4 1, then x is equal to, you have to find out the value of x, right? So here in the left side you can see a determinant 3x x1. You solve that one. Okay, how will you solve that? How will you solve that? You have to find out the determinant, right? 3 into 1 is minus x into x is x square is equal to 3 into 1 is 3 minus 4 into 2 is 8. 3 minus 8, right? Which means 3 and 3 gets cancelled. So minus x square is equal to minus 8. Okay, minus can also be cancelled. So value of x is nothing but plus or minus root 8. Plus or minus root 8. So this root 8 can be written as root of 4 into 2, right? Just a minute. Okay, so that is equal to plus or minus root of 4 into, right? And we know the value of root 4, right? So this is equal to plus or minus 2 root 2. Root of 4 is 2, right? 2 root 2. So what is the answer? D is the answer. Plus or minus 2 root 2. Okay, now we are moving on to the next question. So you are given a matrix A. It is a 2 by 2 matrix. What you have to do is that you have to find out the determinant of 2 into A. You have to find out the determinant of 2A. Okay, so this is, you have to apply the property. Determinant of K into B is equal to K raised n into B, where n is the order of the matrix, square matrix A. Right? So here, since what is the order of the matrix A? What is the order of the matrix A? It is a 2 by 2 matrix, right? So order is equal to 2. Okay, now you have to find out the determinant of 2 into A. That is, you have to take 2 outside. What is the power? It is 2, because order of the matrix is equal to 2 into determinant of A. So what is 2 square? 4. 4 into determinant of A, which is the answer. C is the answer. Okay, now we are moving on to the next question. Which of the following is correct? Okay, you have to find out which is the correct statement. Determinant is a square matrix. No, not all square matrices are not determinant, right? So that is wrong. Determinant is a number associated to a matrix. It is, we cannot find out the determinant of a other matrices, right? We are only dealing with square matrices, so that is also wrong, right? Now, what about the third statement? Determinant is a unique number associated to a square matrix. Yes, that is the definition of a determinant, right? So that is right. So determinant is a unique number associated to a square matrix. Determinant is a unique number associated to a square matrix. So option C is correct. Now we are moving on to the next question. Adjoint of a matrix A is equal to 2, 3, 1, 4. It is very easy because it is a 2 by 2 matrix. In 2 by 2 matrix, if you are asked to find out the adjoint, you just need to interchange the diagonal elements and then change the sign of the non-diagonal elements. So what happens here? Adj of A, we can write in one step itself, right? Interchange the diagonal elements. Interchange 2 and 4. So 4 comes in place of 2 and 2 comes in place of 4. Okay, we have interchanged. Now what happens to the non-diagonal element 3 and 1? You just change the sign of the non-diagonal element, which means 3 becomes minus 3. And what happens to 1? 1 becomes minus 1. So this is our adjoint matrix. Okay, so which is the option? 4 minus 3 minus 1, 2. Okay, D is the option. Now we are moving on to the next question. A be a non-singular matrix of order 3. Then determinant of adj A is equal to, we have studied a property, determinant of adj A is equal to determinant of A power n minus 1. Right, so this is a relation between determinant A and determinant of adj of that matrix. All right, so you are asked to find out the determinant of adj A, and you have given that A is a matrix of order 3, which means n is equal to, here n is equal to 3. Order is 3 means n is equal to 3, which means this is equal to determinant of A power 3 minus 1, right? So that is equal to determinant of A power 2. So which is the option? B option is right. Okay. Now we are moving on to the next question. If A is an invertible matrix of order 2, then determinant of A inverse. Okay, this is, you have to study, this is a property. Determinant of A inverse is nothing but 1 by determinant of A. 1 by determinant of A. Okay, so which option is right? B. So here they have given it in words and here I have written it in the notation. Okay, that is the only difference. Determinant of A inverse is equal to 1 by determinant of A. So option B is right. This is also important. Now, the next one is A and B are invertible matrices. Then which of the following is not correct? You have to tell me which is not correct. Okay. So, what about the first option? Let's check about the second option. A into Aj equal to Aj A into A equal to determinant A into I. It is right. Okay. We have studied it in the properties of Aj, right? So this is right. A into J is equal to determinant of A into I, or J into A is also determinant of A into I. And what is this I? I is the identity matrix, right? And since A and B are invertible matrices, A and B are invertible matrices, which is a necessary condition. Determinant of A and determinant of B should be not equal to 0. Why? Those matrices should be a non-singular matrix. And what do you mean by this non-singular matrix? Their determinant should not be equal to 0, right? So D option is also right. Determinant of A should not be equal to 0. Similarly, determinant of B also should not be equal to 0 since they are invertible matrices. All right. And what about the statement C? AB inverse is equal to, we can write it as B inverse into A inverse. Okay, so let's go on to the first option, A. A into at J equal to, at J into A is not is equal to A into I. It is not equal to matrix A into I. It is equal to determinant of A into identity matrix. All right, so the first option is not right. First option is not right. Okay, now we are moving on to the next question. They have given you a matrix A. If A is equal to is singular, it is a singular matrix, then the value of X is, you have to find out the value of X. They have given a condition that the matrix given is singular. And what is the singular? You have to know what is the concept singular and non-singular, right? Singular means the determinant of that matrix should be equal to 0. If the determinant of a matrix is equal to 0, we can say that the matrix is a singular matrix. All right. So here, how will you find out the determinant? How will you find out determinant? It is a 3 by 3 matrix. You can choose any row or column and expand along that row or column. All right. So I'm choosing the first row. Okay. I'm going to expand along the first row. So it will be 1 into, you have to eliminate this column and this row, right? This column and this row. Okay, so that is equal to x minus 2 1 1 1. Okay, then minus 2 into 2 into, you have to eliminate this column and this row. Okay, what is remaining? 1 1 x1. Okay, plus, now what you have to do? You have to eliminate this column and this row. That is minus 1 into 1 x minus 2 x1. So that is equal to 1 into, you have to find out the determinant, x minus 2 minus 1 minus 2 into 1 into 1 is 1 minus x into 1 is x, right? Minus 1 into 1 into 1 is 1 minus x into x minus 2, right? X into x minus 2. All right, now you have to expand it. So that is x minus 2 minus 1, which means x minus 3, right? X minus 3 minus 2 minus 2x. Sorry, it is plus 2x. Minus 2 into 1, minus into minus, minus 2 into minus x is plus 2x. Then this one will be, first you have to expand inside, right? Minus 1 into 1 minus x into x is x square, minus into minus 2, minus x into minus 2, that is plus 2x. Okay, now this is equal to x minus 3 minus 2 plus 2x. Minus 1 into 1 is minus 1. Minus 1 into minus x square is plus x square. Then minus 1 into plus 2x is minus 2x, right? So on solving this, you get minus 2x and plus 2x gets cancelled, right? Then what will be remaining? X square. Then there is an x here, plus x. Then minus 3 minus 2 is minus 5. Minus 5 minus 1 is minus 6. Okay, x square plus x minus 6. And since it is singular, we know determinant of a should be equal to 0. Here we have got the determinant a, which means this one, this is a determinant, this should be equal to 0, right? So this should be equal to 0. X square minus x square minus, it is actually x, right? X square plus x, right? X square plus x minus 6 is equal to 0. Okay. X square plus x minus 6 is equal to 0. Okay. And now you do the factorization. That is, you have to get minus 6 when you multiply, right? So minus 1 minus you can take 2 and 3, right? So on factorization, you'll get, that is, if you take 2 and 3. 2 into 3 is 6, but you have to get minus 6. And on adding, you have to get plus also. Okay, so you put the larger number plus and the smaller number a minus. So the value will be minus 2 into 3 is equal to minus 6. And minus 2 plus 3 will be equal to plus 1, right? So this is 1. The coefficient is 1. This is how you do the factorization, right? Okay, so you can split this as x minus 2 into x plus 3 equal to 0, which implies x equal to 2 or x equal to minus 3. X equal to 2 or x equal to minus 3. All right. So which is the option? It can be x equal to 2 or x equal to minus 3. So minus 3 is not in the option, which means you can take the value of x as 2. So option A is right. All right, now we are moving on to the next question. If A is a square matrix of order 3 and determinant of Rj is equal to 25, then what is the value of determinant of A? Okay, so they have given the determinant of Rj. Determinant of Rj equal to 25 means we know the relation between determinant of adjoint of A and determinant of A. What was that? Determinant of adj of A is nothing but determinant of A raised n minus 1. Determinant of A raised n minus 1. Here n is equal to 3. Here n is equal to 3. Isn't it? So this is equal to determinant of A power 3 minus 1. Right, determinant of A power 3 minus 1. And what is the value of Rj? Rj is equal to 25. Right, which implies what is determinant of A power 3 minus 1 means determinant of A square. Right, determinant of A square is equal to 25. Right, determinant of A square is equal to 25, which implies determinant of A is equal to plus or minus root 25, which implies what is the value of determinant A? It is equal to plus or minus 5, right? Plus or minus 5. So in option, you can see plus 5. So what is the value of determinant of A? It is nothing but 5 from the options. Okay. Now we are moving on to the next question. So you have given a matrix A and A inverse exists. Then A inverse exists if you have to find out the value of lambda such that the inverse of that matrix should exist. Okay, when you can say that the inverse of a matrix exists when the matrix is non-singular. When is a when will be a matrix become non-singular? When its determinant is not equal to 0. Determinant should not be equal to 0, right? Which means you have to find a lambda such that determinant of this matrix should not be equal to 0. Then we can say that the inverse of that matrix exists. All right. So here you have to find out the determinant of this matrix. That is, determinant of A is equal to, what is the determinant? First element is 2. I'm going to expand it along the first row, because in the first row you can see lambda. So I'm going to expand it along the first row itself. Okay. So 2 into 2, 5, 1, 3, right? You have to remove the first column, first row, right? Okay, so the remaining is 2, 5, 1, 3. Similarly, then you have to put a minus lambda. Then you have to delete the second row, first column, right? Remaining is 0, 5, 1, 3. Okay. Now what you have to do? You have to delete the third row and third column. That is minus 4 into 0 to 1, 1. Right. So that is equal to 2 into 3 is 6 minus 1 into 5 is 5. Right. Minus lambda 0 into 3 is 0 minus 1 into 5 is 5. Right. Minus 4 into 0 into 1 is 0 minus 1 into 2 is 2. Okay. So that is equal to 2 into 6 minus 5 is 1 minus lambda into minus 5. Lambda into minus 5 minus 4 into minus 2. Minus 4 into minus 2. That is 2 minus, sorry, 2 plus 5 lambda. 2 plus 5 lambda. Then minus 4 into minus 2 is plus 8. Right? Which means 5 lambda plus 10. Okay, we have got the value of the determinant, that is 5 lambda plus 10. Since A inverse exists, we know the determinant should not be equal to 0, which means 5 lambda plus 10 should not be equal to 0. Okay, 5 lambda plus 10 should not be equal to 0, which implies 5 lambda should not be equal to minus 10. I'm taking this 10 to the other side. Okay, which means lambda should not be equal to minus 10 by 5. The value of minus 10 by 5, it is minus 2. It is minus 2, right? So lambda should not be equal to minus 2. Okay, lambda should not be equal to minus 2. So which option is right? Option C is right. Okay. There are a few more questions in the session. We'll be continuing in the next section, the 1 mark question itself. All right. I hope the questions that explained until now is clear to you all. Thank you.